This problem is related to the concept of collision and center of mass frame. So a paragraph is given and this paragraph says two particles 1 and 2 each of mass m are connected by a massless spring and are on a horizontal frictionless plane as shown in the figure. So this particle has mass m and this also has mass m and these two are connected by a spring. And this system is kept on a horizontal plane and this plane has mu equals to 0, that is frictionless, friction coefficient is 0. Initially the two particles with their center of mass at x naught are oscillating with amplitude A and angular frequency omega. So initially this is the center of mass that is at x naught and this system is oscillating. This is oscillating with amplitude A and this is also oscillating with amplitude A and angular frequency is given and this is equals to omega. Thus their positions at time t are given by x1t which is equals to x naught plus d plus a sin omega t and x2t which is equals to x naught minus d minus a sin omega t respectively, and it is also given that d is greater than 2a. So now I know position of this particle at any point of time, that is x1t, and position of particle 2 at any point of time, that is x2t. If you observe closely, this is x naught plus d. So this is x naught and x naught plus d will be somewhere here. And then a sin omega t. So this is about x naught plus d, this is going a sin omega t and this is also going a sin omega t in the both direction. This means the maximum value will be plus a and the minimum value will be minus a. So about this position, that is x naught plus d, this is going a distance this side and this is also going a distance this side. Similarly, the particle 2, this is at mean position is at x naught minus d. So this position is x naught minus d will be somewhere here, and from this position, that is the mean position, this is going a distance this side and then coming and this is again going a distance this side. So this is making an SHM. Particle 3 of mass m moves towards this system with a speed u naught which is equals to a omega by 2 and undergoes instantaneous elastic collision with particle 2 at time t naught. So the third particle is moving and it is coming with a speed u naught and this collides with particle 2 and the collision is elastic, instantaneous, so it happens suddenly. Finally, particle 1 and 2 acquire center of mass speed vcm and oscillate with amplitude b and the same angular frequency omega. So once this collision occurs, this center of mass starts moving and center of mass has a velocity of vcm and this oscillate with a bigger amplitude, let us say b, but the angular frequency is same, omega. If the collision occurs at time t naught equals to 0, it is given that t equals to 0 this collision occurs, then we have to find what is the value of velocity of center of mass divided by a omega. So let us try to do this problem. So we have been given position of particle 1, that is x1t, as I said earlier also. So this is x naught plus d, so this x naught plus d is somewhere here, and then a sin omega t. So maximum value of this will be plus a and minimum value will be minus a. So from x naught plus d, this is going a distance this side and this is coming a distance this side. So from x naught plus d, this is making an SHM with an amplitude of a. Similarly, this gives position of particle 2 and this is x naught minus d. So, this is x naught and d will come this side because negative. So, this is x naught minus d, and then maximum value of this is a and minimum is minus a. So, from this position this is going a distance this side or this is going a distance this side. So, this is making an SHM of amplitude a. Now, let us find the velocity. What is velocity? Differentiation of x is velocity. So, dx1 by dt is v1 and differentiation of this is 0 and this is constant. So, I will have a, and differentiation of sin omega t is omega times cos omega t. So, this is v1. Similarly, I can differentiate this expression. Then I will have v2 and this is equals to, this will be 0 and this will be minus a omega cos omega t. So, we have to find at t equals to 0. So, let us find velocity at t equals to 0. What will be v1? So, if you put t equals to 0, so this is cos 0 is 1. So, velocity is a omega. So, v1 is equals to a omega, and what will be v2? This is 1. So, v2 will be minus a omega. So, this means particle 1 is going in this direction with velocity a omega and 2 is going in opposite direction because of minus sign, and this has a magnitude of a omega. We can also find their x coordinate. So, if I plug t equals to 0, this will be 0 because sin 0 is 0. So, x naught plus t is the coordinate of particle 1 and x naught minus d will be the coordinate of particle 2. So, the collision is elastic. In the problem it is given that this particle 3 collides with this and the collision is elastic. Now, if you remember, in elastic collision what happens? If I have two masses and both are equal, in that case if the collision is elastic, then velocity gets interchanged. So, that is the idea. So, this is before collision, that is, this was moving with a omega speed and this was moving with a omega speed, velocity of 1 and velocity of 2 and position of 1 and position of 2. So, I know everything in this figure before the collision. So, this figure depicts the situation before the collision. Now, this particle is coming and it will collide with this particle. So, this is the collision, and then this situation depicts after the collision. So, what will happen? This velocity u naught and this velocity a omega will get interchanged because this mass and this mass is same. So, this velocity u naught I will get to this mass. So, this means now this particle will have a velocity of u naught and this will be interchanged to this. This means now 3 will have a speed of a omega in this direction. So, velocity got interchanged. So, after collision I can find what is the velocity of center of mass. So, velocity of center of mass is given by this formula, that is m1 v1 plus m2 v2 divided by m1 plus m2. So, this is the situation. Now, see, the particle 1, the velocity of particle 1 will not be disturbed because it has not gone any kind of collision. So, we can find. So, if I write for 2, so this is m times u naught, that is for 2, and for this m times a omega, that is for this one, divided by m plus m, that is 2m. And in the question it is given that u naught is equals to a omega by 2. So, if you solve, then this becomes 3 by 4 omega. 3 by 4 is 0.75 a omega. So, VCM this was BCM divided by A omega is basically 0.75. So this is the answer for the first part of this problem of this paragraph. This paragraph also has a second question. And the second question says, if the collision occurs at time t naught, which is equals to pi by 2 omega, then what is the value of this term? That is 4b square divided by a square. So now collision occurs at this time. So let us first find position and velocity of this particle and this particle before the collision. So position is given by this formula. So if I put x equal t equals to pi by 2 omega, so this will be pi by 2 omega, so this is 1 sin pi by 2. Sin pi by 2 is 1. So the position will be x naught plus t plus a. So this is at extreme position. And what is the position x2? This is again 1. So this is x naught minus d minus a. So this is at one extreme and this is at another extreme. So this particle is on the extreme side and this is another extreme side. And velocity is given by this formula. So if you put pi by 2 omega, so cos pi by 2 is 0. So velocity of 1 is 0. And this is also pi by 2, because if you put t equals to pi by 2 omega, omega will cancel, I will have cos pi by 2. And cos pi by 2 equals to 0, so V2 is 0. So this particle at its extreme position, this is also extreme position, and velocity of both are 0. And this happens basically in case of SHM. At extreme position, velocities are 0. So this is the situation before the collision. Now this particle is coming and this is going to collide with this. Collision is elastic, so velocity will be interchanged because masses are equal. So collision occurs at this time. We know V1, V2, and if I know V1, V2, then I also know VCM, because M1 V1 plus M2 V2 divided by M1 plus M2, and both velocities are 0. Basically I know velocity of center of mass, that is 0. This is one extreme position and this is another extreme position. So this is position of x1 and this is position of x2, that is particle 2 and particle 1. So both are at their extreme position. And when collision occurs, the velocity gets interchanged. So this has a 0 velocity. So that is particle 2 has a 0 velocity. So this means after the collision, this will have 0 velocity. And this was having a speed of u naught. So this will be given to this. So particle 2 will have a speed of u naught in this direction. And this particle still has a speed of 0 because initially it was having 0 speed. Now this is the same figure before the collision and this is after the collision. The value of u naught is given, that is a omega by 2. Now let us find velocity of center of mass using this formula, that is m1 v1 plus m2 v2 divided by m1 plus m2. Now in this case m1 is m 0 and this is m and v is a omega by 2. So if I plug this value, so this is 0 and this is u naught, I can plug u naught equals to a omega by 2 and this is m1 plus m2, that is m plus m. So this will be a omega by 4. So this means center of mass is moving with a speed of a omega by 4. Now from here I can solve this problem either using the center of mass frame or without using the center of mass frame, that is absolute ground frame. Center of mass frame makes the problem easy. So what is this? So let us say this is my center of mass. So if somebody sits on the center of mass, basically his velocity will be a omega by 4. Now with respect to his velocity or with respect to him, what is the velocity of particle 1? He himself is moving with velocity a omega by 4. So he will see this particle is coming in this direction with a speed of a omega by 4. How to find that? So with respect to center of mass, if you want to find velocity of any particle, what you do is you simply subtract the velocity of center of mass from the velocity of that particle. Velocity of this particle is 0, and if I subtract a omega by 4, then velocity of this particle will be minus a omega by 4. Minus sign shows this will be moving in this direction with a speed of a omega by 4. So this will have a speed of a omega by 4. And what about this? Once again, I have to subtract in this velocity a omega by 4. So a omega by 2 minus velocity of center of mass, that is a omega by 4. So a omega by 2 minus a omega by 4 is equals to a omega by 4. So this is moving in this direction with a speed of a omega by 4. And center of mass itself is moving as a omega by 4. But if you sit on the center of mass, you will simply see that this particle is coming with a speed of a omega by 4, and this particle is coming with a speed of a omega by 4. So basically, if you sit on the center of mass, it is same as like a ground frame. In center of mass frame, it will look as if like it's from the ground frame if the center of mass was not moving, center of mass was at rest. So in center of mass frame, this is doing SHM and this is also doing SHM. So in CM frame, this is coming with a speed of a omega by 4, and this is also coming with a speed of a omega by 4. And center of mass is rest. Even though center of mass is moving, but you are on the center of mass. So in your frame, center of mass is at rest because you are the center of mass frame. Now if you remember velocity, if this is doing SHM, then velocity is given by this formula. So this is a general formula to calculate velocity. Velocity is equals to omega times a square minus x square, where a is the amplitude and x is the position. Now this is at extreme position, this means x equals to a and velocity is a omega by 4. So if I plug this, so this is a omega by 4 and this is omega, and in the question it is given that amplitude is b, so this is b square, and x at this instant is a because this is at its extreme position. So b square minus a square. If I square both sides, I can write a square omega square by 16, and this is equals to omega square b square minus a square. And if I simplify, then I will have 17 by 16 a square equals to b square. So from here, I can calculate 4b square by a square, and this value is equals to 4.25. I hope you enjoyed this problem, and this problem is really a good problem in the history of IIT JEE Advanced problems. Even though this is a theory is well known, but application of this problem in the exam setting is really important. I hope you like my videos, and if you like, please share with your friends, subscribe to my channel and like this video. I will see you in the next video. Thank you.